Nomenclature of bicyclic compounds. iupac nomenclature of bicyclic compound. Tell me, so what are the bicyclic compound? Take this example, which is having two cyclic rings now. Let us take this is a bicyclic compound. Tell me, in this bicyclic compound, the carbon atom which is attached to like three different three atoms, which is called a bridgehead carbon. Take down. Bridgehead carbon. Film. And this is also bridgehead carbon. Bridgehead carbon. Right, so bicyclic compound contain two bridgehead carbons. This is a bridgehead, it is also bridgehead carbon. Then what about this carbon? This carbon, these carbons are called what? Bridged carbons. Okay, so these carbons are bridged carbon. Okay, so therefore to write the iupac name of the bicyclic compound, you must remember what is a bridgehead carbon and what are bridged carbon, because we use in nomenclature these terms. So there are two bridgehead carbons. Okay, so what is the bridgehead carbon? The carbon which is connect the two bridges. Like this is one cyclic ring, another cyclic ring. So two cyclic rings are connected by this bridgehead carbon. Right, it is also bridgehead carbon. Then what are the bridged carbon? The carbon atom which is present in cyclic ring, like 1 2, it is a 1, it is 1 2. Okay, then now let's say what is the way what is iupac name of bicyclo compound? It's very simple. See, while writing the name of the bicyclic compound, the word bicyclo should be written first. We need to write what? Bicyclo. So the word bicyclo, listen first, bicyclo should be written first, then followed by number of bridgehead carbon should be written like 1 2 1 1 2. The number of bridgehead carbon should be written in the descending order. Tell me here, descending order means there are two bridgehead carbon, there are two bridgehead carbon, bridged carbon, there are two bridged carbon and one. Therefore then we should write number of bridged carbons. How many bridged carbon? 2 2 1. It should be in descending order, decreasing order. 2 comma 2 comma 1. Bicyclo 2 comma 2 comma 1. The next, the name of the alkane should be written. Then total how many carbons are there? Alkane 1 2 3 4 5 6 7. Therefore its name is heptane. Isn't it? Okay, I repeat once again carefully. Listen carefully. While writing the name of the iupac name of the bicyclic compound, the word bicyclo should be written first. Then the number of bridged carbon should be written in a square bracket. That to descending order, in decreasing order. Right. First is a more number of bridged carbon 2 2 or else 2 2. This is 1 2 2 1. The name of the alkane should be written. Okay, right on. First you take this, what is a bridgehead carbon? What is bridged carbon? Right on. Write the rule. While naming the bicyclic compound, while naming the bicyclic compound, the word bicyclo is written first. The word bicyclo is written first. Then number of bridged carbon atom should be written in square bracket. Then number of bridged carbon atoms should be written in square bracket. In decreasing order or descending order, right? In descending order, followed by name of the alkane should be written, So take this example. Next, and tell me what is the iupac name of this? Tell me. So it is also bicyclo. There are two cyclic ring. Bicyclo in square bracket. Write the number of bridged carbons. 1, it is 0. 1 no bridged carbon. 1 only. It is no bridged carbon. 0. Therefore 1, 0. Then meth, eth, prop, butane. Next. Tell me. Bega. Bicyclo. So how many bridged carbons? 1, 2, 3. Here is 1, 2, 3, 4. Yes or no? You leave this bridge head. Don't include bridge head carbons. Okay. 1, 2, 3. 1, 2, 3, 4. In the descending order. 4, 3, 0. Next, total number of carbon atoms. It is 6 plus 3, no? It is 6, 7, 8, 9. Therefore, nonane. Next. Bega. Write fastly. So write the iupac name of this. Bicyclo. So it is a bridged carbon. Leave the bridged carbon. 1, 2, 3, 4. 1, 2, 3, 4. So 4, 0. Decane. Right? Next. Bicyclo. 2, 2. Very good. 2, 2. Octane. Yes or no? Next. Bicyclo. 3, 1, 0. Hexane. 6 carbons. Hexane. It is bicyclo. See, these two are the bridged carbons. Okay. Then that is bridged carbon. 1, 2. It is 1. So 2 comma 2 comma 1. Total how many carbons? Heptane. Bicyclo. So 2 2 2. 2 comma 2 comma 2. Octane. So already written now. Where? See, both are same. Right? Write this iupac name of will you write the iupac names? Tell me, it is bicyclo 4 comma 1 comma 0 heptane. Next, bicyclo 4 comma 3 comma 0 nonane. Okay, will you write remaining all? Okay, write later. Next, right? Take the structure, write the iupac name later. Right, so this is the iupac nomenclature of bicyclic compound. Simple bicyclic compound, but suppose if there is a substituent or functional group or multiple bond, then what is the iupac nomenclature? Let us take, it is a 6-membered ring and having, here is methyl group. Okay, then what is the numbering? Now of course you can write, it is a simple, if there is no methyl, what is iupac name? Bicyclo 4 comma 1 comma 0 heptane. But when there is a methyl group or double bond or triple bond or functional group, then numbering should be given, right? So then how do you give numbering and what is the iupac name? Okay, write that one statement. Right, if bicyclic compound contain, if the bicyclic compounds contain substituent over or multiple bonds or functional groups, functional groups, then number should be starts from bridge head carbon, then number should be starts from bridge head carbon, proceeding first along the longest bridge, proceeding first along the longest bridge, then along the long bridge, proceeding first proceeding first along the longest bridge, proceeding first along the longest bridge, then along the long bridge, then shortest bridge should be named last, shortest bridge should be named last. Okay, right, see now if there is a substituent or functional group or even multiple bonds are present, then numbering should be start from bridge head. Either this is a bridge, right, bridge head carbon, you can start from either here or here, 1. Numbering should be start from bridge head carbon, then proceeding first through the along the longest bridge, then next is long bridge, then next is shortest bridge. Again it is a descending order. Then how we have written numbering descending? No, numbering descending written, no, therefore this is also descending. So give the numbering from the longest bridge. Which is the longest bridge? 1 2 3 4, it is 1, it is no bridge, therefore this is 1, it is 2 3 4 5, the next is 5, it is of course 6, this is 7. If there is 0, no numbering, therefore 1 2 3 4 5 6, then 7. Then what is iupac name? So while writing iupac name, we write the first substituent. Which substituent is here? 7-methyl, therefore 7-methyl, then bicyclo. So then remaining things are same, 4, 1, 0 heptane. Okay, so this is the same bicyclo, we have written bicyclo 4, 1, 0 heptane, but in addition to that what we should write? 7-methyl, because methyl substance should be written first, no, in iupac name, like 2-methyl propane, methyl will be written first, then next is propane. Even though, yes, so even though substituent gets here, no, suppose if you give a numbering here 1 2, substituent get least number, okay, even though substituent get least number, you need not to bother about this. Okay, there is a rule, give the numbering first from longest bridge head, longest bridge, then short bridge, then shortest bridge. Okay, so even though substituent, functional group, whatever the group are present on the wherever it is, your numbering should be like that only. This is the decreasing order, no, numbering should be in decreasing order. I hope you understand. Tell me. Here center carbon. Okay, take that example. If there is a something, it is bromo. Tell me, your numbering should be start from bridge head carbon, either this or this, then proceeding first along the longest bridge, 1 2 1 2, both are same, therefore I will give 2 3 4. The next is long bridge, 5 6, next is shortest bridge, 7. Therefore what is iupac name? 7 bromo. Okay, bicyclo, other things are same, 2 2 1 heptane. Okay, one more example. Write the IUPAC names. Okay, tell me. So first, to try to understand giving numbering. If you give the proper numbering, the IUPAC name is almost you can done. You can write it. Tell me. First, bridgehead carbon should get number 1. The next is, so it should be proceeding. Okay. So along the longest bridge, 1, 2, 3, 1, 2. Therefore, it should be 2 and 3. And one more. See. You need not to take always 1, you can take here also. Suppose if you give from here 1, 2, 3, methyl get same numbering, no? The general rules are same remaining. It is 4, 5, 6, 7. Therefore, it is a 3-methyl bicyclo. So 3, 2, 0 heptane. Okay, next. Now here also numbering you can start from either this bridge or this bridge carbon, bridgehead. Okay, suppose if you take from here 1, 2 you will get. If you take here 1, 2, therefore both the side you will get same numbering. And next, number of bridge carbon 1, 2, 1, 2. If the both the side having same bridge carbon 1, 2, 1, 2, 1. That's what now give the more priority to double bond. The remaining rules are same. So 2, 3, 4, 5, 6, 7. And tell me, it is bicyclo. So 2, 2, 1. Hept. Which in? 1, 2 in. So will you write remaining? So here numbering, this is 1, right? So 1, 2, 3, 4, 1, 2, 3, 4, it is no carbon. So therefore, when both the bridgehead having same, bridgehead carbon having same numbering, no, here also bridge carbons are same numbering, then tell me what to do. Then we need to take priority to the substituent. Then 1, this is 2, 3, 4, 5, 6. The next is what? 7, 8, 9 and 10, decane. Okay. So take the structure, write later. Next, iupac nomenclature of spiro compounds. Any doubts here? Will you do it? Next, right? So iupac nomenclature of spiro compounds. Okay. See, what are spiro compounds and their nomenclature? See, spiro compounds is these also bicyclic compound. These are also bicyclic compound, but two bicyclic rings joined together by this quaternary carbon. This is a quaternary carbon. right? So if two cyclic rings are joined together by quaternary carbon called spirocarbon. This quaternary carbon called spirocarbon, and the compounds are called spiro compounds. Then what is the difference between spiro compounds and bicyclic compound? These are also bicyclic compound, but in case of spiro compound, so two cyclic rings are joined together by one carbon, that is one common carbon, that which is called what? Quaternary carbon, right? That means if two cyclic rings joined together by quaternary carbon called spirocarbon, and compounds are called spiro compounds. Okay, then what is the iupac nomenclature of spiro compounds? Right, while naming the spiro compounds, the word spiro should be written first, like bicyclo. Here we should write what? Spiro. The word spiro should be written first, then number of bridged carbons. So how many number of bridged carbon? 1 2 3 1 2 3. Okay, anyhow this is a common carbon, it is not a bridged carbons here. There is no bridged carbon, it is always 0, you need not to take. Therefore 1 2 3 1 2 3, it is a 3 comma 3. So spiro 3 comma 3, it is meth. How many carbons are there? Meth, eth, prop, but, pent, hex, hept. It means heptane. 3 comma 3 comma not 1. This is a spirocarbon. Spirocarbon should not be taken. In all the compound you will get spirocarbon only. Spirocarbon should not be taken like 1. Okay, then if there are different number of carbon, like here 3 3 is there, you have written 3 3. If there are different number of carbon are there, then you should write descending order. No, sorry. No, here you have written descending, no? Then here it should be ascending order. In increasing order should be written. Right? For example, it's quite opposite. If it is the spirocarbon having 6 carbon here and 3 carbon here. Okay, it is a spirocarbon. And tell me, what is the name? Spiro. So now 1 2 3 4 5 1 2. So the number of bridged carbon should be written in the ascending order. It's opposite to this. There you have written descending order. Here should be ascending order. In ascending order 2 comma 5. You need not write 0. This is a spirocarbon should not be represented. It is understood the spiro will be there. So therefore total carbon atoms are 8. It is octane. Okay. So the quite opposite to this. Then here you need to remember we should write spiro, and this is the ascending order. Suppose if there are substituents are there, if there are substituent or functional group or multiple bonds are there, again it should be written opposite to that. Now here what you have written? Here we have given the numbering to where? No, first number given to what? Bridged head carbon. It is called bridge head carbon. So numbering must be start from bridge head, either 1 1. But here numbering should be start from adjacent to the bridge head. That means next to the spiro compound. Next to the spirocarbon. It is a spirocarbon. Next to spirocarbon is this or this or this. Okay, there are carbons next to the spirocarbon. Numbering should be start from next to spirocarbon and proceeding first what? Proceeding first shortest bridge to longest bridge. Here there are only 2 bridge. Shortest, longest. No short. Okay, there is a middle is a spirocarbon. Therefore it is opposite. Now here how it is, 2 5 increasing, no? So we are writing number of bridged carbon in the increasing order. Here also we should write increasing order. First is shortest, then longest. Therefore it is a 1, it is 2. Right. Then tell me 3 4 5 6 7 8. If there are substituents are present, you can give the numbering. Then suppose here methyl is there. If there is a methyl here, what do you write? 5 methyl, then spiro, other things are same. If double bond is there, double bond should come last, oct plus in. Which in? 2 3 in, 5 in, 4 in, something. Okay, this is the iupac nomenclature of spiro compounds. Right on? Tell me, any doubt? Right on. First write this. Right, if two cyclic rings are joined together by quaternary carbon, if the two cyclic rings are joined together by quaternary carbon called spirocarbon, and compounds are called spiro compounds, okay. Take this first one. Next, while naming the spiro compounds, the word spiro should be written first. Then number of bridged carbons, should be written in square bracket. Number of bridged carbon should be written in square bracket. How it is, ascending or descending? Here ascending order, in ascending order, followed by name of the alkane, should be written. Okay, so take 1-2 examples, this and this. Right, if the substituents are functional groups, next, right, if the substituents are functional groups or multiple bonds are present, then numbering should be starts from carbon atom next to spirocarbon, underline. Numbering should be start from carbon atom next to the spirocarbon, and proceeding through the smaller ring, first. Okay, take some example. Write the iupac name. Already. Okay, tell me. So you can write till here, you can do it. This one, what is the iupac name of this? If there are substituents present on the spiro compound, numbering should be start from where? Carbon atom which is next to the spirocarbon. Next to the spirocarbon. This is the spirocarbon, no, next to spirocarbon, next to spirocarbon. This is also next to the spirocarbon. So then, where the numbering should be started? From first smallest, right? Smallest ring has to be given more priority. Therefore, it means numbering 1 or 1 should be started. Then methyl is there, U1. It is 2. Then 3, 4, 5, 6, 7. Therefore, it is 1 methyl. Then spiro. So 2 comma in the ascending order. 2 comma 4, not 0. Spiro, in spiro you should write only 2 numbering. Then heptane. Right, so that you can write. It is same. Now here, this is a next to spiro, next to spiro. It is also, there are 4 carbons are next to the spiro. The numbering should be start from first shortest ring. Shortest ring is 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4 no. Therefore, it should be start from here no. Here or here. And here, suppose if you take here 1, 2, 3, 4, 5, 6. Yes or no? Suppose here 1, 2, 3, 4, 5, 6. So it will get same. That's what I'll take 1, 2, 3, 4. This is 5. I'll take 6 here. 6 can, after 5, 6 can be given here, no? 8, 7, 8, 9, 10. Then it is a spiro. Tell me. 1, 2, 3, 4. 4 comma 5. Dec no. Dec 6 in. Tell me. Huh? This one. So start the numbering next to the spiro. This is or this or this or this. Tell me. It should be short ring first, no? Suppose if you give here 1, 2, 3, 4, 5. If you give here 1, 2, 3, 4. No, 1, 2, 3, 4, 5. Same no? Yes, ring should be complete apicala. If you give 1 here, you cannot give 2 here, no, right? The ring should be complete first. 1, 2, 3. Then ring, that's what, no, short ring first. Small ring first. 1, 2, 3. Small ring is over. Then large ring. Third one. This one. It is spiro, no. You need not, numbering is not required. 11 carbon. What is called 11 carbon? Undecane. Undecane, dodecane, tridecane, tetradecane. Okay, so take some homework questions, do it later. Write the iupac name of followings. Take. Okay, will you write it later? So nomenclature of all organic compounds completed. Next slide, isomerism. So in coming weekend exam there are 4-5 questions based on this spiro and bicyclo nomenclature. It get confused. You need to practice. Okay. Next, right? Isomerism. Tell me. So what is a iso? Iso means same, right? Mer means parts. Even I have studied iso. Ninth, which is it spiro? Bicyclo. It is spiro. First of all, you should be able to identify spiro, which is bicyclo. So notice spirocarbon is, there should be a quaternary carbon like this. iupac name of following. It is spiro, bicyclo, spiro. I have given mixing. Right. In exam they won't give like write the spiro compound, iupac name of spiro compound, right? That you should be able to identify which is spiro, which is bicyclo. Okay, right. Listen. So isomerism. Iso means same, parts, mer means parts or units. Even you have studied in where polymers topic, right? Okay, then. So then in this topic we are going to study, there are two type of isomerism. Okay, one structural and stereo. Now let's see first what is isomerism. Say isomerism in the sense, the organic compound which are having same molecular formula will be same. but they have different physical and chemical properties called isomers, and this phenomena called what? Isomerism, right? The molecules are organic compounds which are having molecular formula will be same. So organic compound which are having same molecular formula, but what is the different? They have different physical and chemical properties called isomers and phenomena called isomerism, right? Then isomerism in organic compound further classified into basically two types. One, structural isomerism and stereo isomerism. Therefore isomerism is of two types in organic chemistry. That is one, structural isomerism. See, one question can be expected in NEET. So structural isomerism, this structural isomerism is also called skeletal isomerism or skeletal isomerism. Next is stereoisomerism. Stereoisomerism. Stereoisomerism is also called space isomerism. Right? So therefore isomerism basically two type, one structural, second one is stereo. Then structural isomer further classified into six types. One, so one, chain isomerism. Two, positional isomerism. 3, functional isomerism. 4, ring chain isomerism. 5, metamerism. And sixth one is tautomerism. But among this tautomerism concept is very, very important to understand organic chemistry. Remaining all are just definition, 2-3 example you can remember. But tautomerism is concept is important to understand, particularly organic mechanism. Okay, it is about structural isomerism. This chain isomerism is also called it is a nuclear isomerism. Okay, then next is stereoisomerism. Stereoisomerism further classified into two types. Okay, one is a conformational isomerism. Okay, we will study conformational isomerism in alkene topic. Do you remember? Eclipse conformation, staggered conformation, fully eclipsed, right? That is conformational. Next is configurational isomerism. Right. This configurational isomerism further classified into two types. That is geometrical isomerism. It is also called cis trans isomerism. Second one is optical isomerism. Optical isomerism is also called tell me. Optical isomerism also called enantiomerism. So this is a brief classification of isomerism. Okay, this once again. So what is isomerism? We know it. Same molecular formula, different physical and chemical properties called isomers, and phenomena called isomerism. Isomerism of basically two types, structural and stereo. What is a structural isomerism? Structural isomerism is the organic compound which are having same molecular formula, but they differ in what? Structure. same molecular formula, different structural formula, means different structure. If organic molecule having same molecular formula, different structure, they are called structural isomers, and phenomena called structural isomerism. Next is stereoisomerism. The organic compound which are having same molecular formula, but they differ in what? They differ in the spatial. They differ in spatial arrangement. The spatial arrangement of atoms or groups called stereoisomerism. Stereoisomers and phenomena called stereoisomerism. It is also called space isomerism. Okay. Then we will study one by one in detail. Right till here. Isomerism. Right quickly. The organic compounds which are having same molecular formula. The organic compounds which are having same molecular formula. Same molecular formula, but different physical and chemical properties. But different physical and chemical properties called isomers, and phenomenon is called, and this phenomenon is called isomerism. And this phenomenon is called isomerism. Next, you take like this: isomerism classified into structural and structural is not, take structural, also called constitutional, or constitutional. And that is space. Yeah, chain isomerism is called nuclear or skeletal. Here is, you can write skeletal. Nuclear or skeletal isomerism, that is chain isomerism. Take as this. Structural further classified into 6 types. Chain, position, functional, ring chain, metamerism, tautomerism. Stereo further classified into 2 types. It is a conformational isomerism and configurational isomerism. Conformational, configurational. Then configurational, again 2 types: geometrical, which is also called cis trans, and optical, which is also called enantiomerism. Okay. Structural isomerism or constitutional isomerism. Constitutional isomerism. Right. The organic compounds which are having same molecular formula, structural isomerism. The organic compounds which are having same molecular formula, but the organic compounds which are having same molecular formula but different structure. but different structure called structural isomers, but different structure called structural isomers, and phenomenon is called structural isomerism, and this phenomenon is called structural isomerism. Okay, then next is, let us see one by one. First, chain isomerism. See, chain isomerism, now here onwards I called CI, and positional isomerism PI, functional isomerism FI, ring chain it is a RCI, and metamerism MMR, and tautomerism TMR. Okay. So take down first one, chain isomerism. Can you tell me? So definitions are so simple. What is chain isomerism? What are the chain isomers? The organic compound which are having same molecular formula, but they differ in what? Either side chain or parent chain. So chain isomers differ in either side chain or even sometime parent chain also. Then they are called what? Chain isomers, and phenomena called chain isomerism. Therefore, you need to remember chain isomers differ in either side chain or parent chain. Next to positional isomer, the organic compound which are having same molecular formula, but what is the different? They differ in the position of either substituent or position of multiple bonds or position of functional groups, right? Therefore, positional isomers differ in either position of multiple bond or substituent or functional group, but molecular formula is same. Next, functional isomerism, the organic compound which are having same molecular formula, but they differ in what? Presence of functional group. And ring chain, the organic compound which are having same molecular formula, but they differ in the mode of attachment of carbon-carbon bond. One, like in ring chain, one is a open chain will be there with same molecular formula, other forms cyclic ring. That means mode of attachment of carbon-carbon bond is different, right? One is a cyclic ring, another one is a open chain, and tautomerism is separately we will study. So therefore, let us see, first is chain isomerism. Okay, then now tell me, what is the condition for chain isomerism? Same condition. First condition is they must have what? Same molecular formula. Second condition, molecular formula is same, and second condition is if they have functional group. If the molecule has functional group, they must have what? Same functional groups, right? That means, so if molecule exhibit chain isomerism, they must have same molecular formula. If the functional group is present, the functional group must be same. In position also same. So in positional isomerism, so molecule must have same molecular formula, that is fixed. Along with same molecular formula, if there is a functional group, the functional group must be same. It means in CI and PI, both should have same functional group, same molecular formula. But in case of FI, molecular formula is same, they change in functional group, they differ in functional group. Okay, that is a condition. Next is ring chain. So they have, one is a cyclic ring, another one is a open chain. Okay, right on. So first one, chain isomerism, it is also called, once question asked it is given by this skeletal. So skeletal is not a structural, skeletal is a chain isomerism. Right on. Chain isomerism, the organic compound which are having same molecular formula, the organic molecule which are having same molecular formula, but they differ in what? But they differ in parent chain or side chain, underline, parent chain or side chain, called chain isomers, called chain isomers, and this phenomenon is called chain isomerism. And this phenomenon is called chain isomerism. Okay, tell me condition 1. So first is they should have, take down, they should have same molecular formula. Molecular formula should be same. 2, if functional group is present, if the functional group is present, they must have same functional group. Okay. So therefore they should have same molecular formula 1, and if the functional group is present, they must have same functional group. Okay. For example, tell me, it is a N-butane. Yes or no? N-butane. This N-butane has how many total number of carbon atom? 1, 2, 3, 4. A parent chain has 4 carbon atom. Now write the parent chain with 3 carbon atom. CS3, CH, CS3, CS3, which is called isobutane. Tell me, now N-butane, isobutane, both will have same molecular formula or not? Molecular formula will be same. If you see the molecular formula, C4H10 you will get. C4H10. So molecular formula is same, but what is the difference? This parent chain has 4 carbon atom. This parent chain has 3 carbon atom. Therefore, they differ in the number of carbon atom in a parent chain. Even number of carbon atom side chain also possible. Next, one more example. CH3, CH3, CH2, CH2, CH3. It is called N-pentane. Okay, N-pentane contain how many total carbon atom? 1, 2, 3, 4, 5. So will you write 4 carbon atoms in a parent chain? Tell me, what is this? 1, 2, 3, 4. 4 carbon atom, and it is a isopentane. Then will you write 3 carbon atoms? 1, 2, 3, 4. No. You can also write 3 carbon atom in a parent chain. How? Neopentane, right? It is a neopentane. And tell me, N-pentane, isopentane, neopentane, all 3 are having same molecular formula C5H12. But one has parent chain. How many carbon atoms? There are 5 carbon atom. Parent chain 4 carbon atom. Parent chain only 3 carbon atom. They differ in the number of carbon atom in a parent chain. Therefore, N, iso, neo pentanes are example for chain isomers. That means chain isomer may be differ in parent chain. Even they may differ in side chain also. For example, let us take one more example with side chain. If it is a cyclohexane having ethyl group, ethyl cyclohexane, then tell me, now side chain has how many carbon atom? Side chain has 2 carbon, no? Ethyl hexane. I will make it is a dimethyl hexane. Tell me, ethyl cyclohexane, dimethyl cyclohexane are example for what? Chain isomers. Because here side chain is 2 carbon atom, side chain is 1 carbon atom. They are the chain isomers. Okay, but in chain isomers, one important point, the number of chain isomers increases with increasing number of carbon atoms. But the one more important condition is for chain isomerism, organic molecule at least, organic molecule minimum at least it must have how many? 4 carbon atom. For example, it is N-butane. We will write the chain isomerism with 3 carbon atoms. It's a 3 carbon atom. If you want to write one more chain isomer for this, we should write 2 carbon atom. So 2 carbon atom take parent chain. Okay, 2 carbon atom, you write 1 methyl group here. Both are same, no? Right? That means for chain isomerism, organic molecule must have a minimum, how many? 4 carbon atom, butane. So therefore, minimum 4 carbon atom should be there. Next, as the number of carbon atom increases, see, it is a butane, how many isomers? Ci is 2. Next, pentane, Ci is 3. As the number of carbon atom increases, chain isomers is increases. Okay, so therefore, these 2 points also should remember. One, minimum carbon atom should be 4 to exhibit chain isomerism, and as the number of carbon atom increases, chain isomerism is increases. Okay, have taken these three example. Next write one note. Right, so note, right, one first point, right, molecule having minimum 4 carbon atom, can exhibit chain isomerism, comma, as the number of carbon atom increases, what happen? Chain isomerism is increases. Okay, so take one important data. Number of carbon atom, let us take 4. So with 4 carbon only possible, no? C4, H10, C5, H12, alkane. I am writing alkane. C6, 14, C7, 16, C8, 18, C9, H20, C10, H22. Okay. Then what is the number of chain isomers? 1. So already written, no? How many Ci? 2. Next, this is how many Ci? 3. Then with the 6 carbon atom, remember it is a 5. By adding these 2, you will get this. Remember like that. Next, after 5, you will get 9. There is no any formula to get this. We should write all possible structure, that's it. 9, make it double, 18. 18, make it double, but 35. Then next is 75. Okay, so remember the numbers. There is no any formula to get number of isomers. Don't expect any formula. Formula is not there. If question is asked, you should write all possible structures. Okay. Then for example, what is the number of chain isomers with C6H14? Okay. With C6H14, how many chain isomers are possible? And sometimes they ask iupac name also. Which of the following isomer is not possible or possible with this molecular formula? So therefore, you do like this. It is 6 carbon, no? 1, 2, 3, 4, 5, 6. This is 1. Okay, 6 carbon. Next 5 carbon. You make it 5 carbon, 1, 2, 3, 4, 5, and I will write 1 here. Okay, it is 1, 2, 2 methyl. Will you write 3 methyl? This is one more possibility. Will you get 4 methyl? 1, 2, 3, 4. Again same will get 2 methyl only. So that means, with 5 carbon, these 2. With 5 carbon, 6 carbon, 1, 5 carbon, 2. Next, is it another possibility is there for 5 carbon? No, 4 carbon. Make it now, chain is 4 carbon. I will make 2 here, dimethyl. Next, write another possibility, 4 carbon atom, methyl, methyl. Okay. Next, any other possibility? No. If you write another carbon here, it become this only. Not possible. Next, 3 carbon. So write the 3 carbon atom, and how many still carbon should be done? 3. Where write 3? 1 right here, 1 more right here, another should be either here or here, 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 anywhere. Write this. I'll give. Okay, that means no other possibility. Therefore 1, 2, 3, 4, 5. Therefore got it, 5. Right. So like this, which is not possible, they may. So these are the possible. These iupac names you can write. They may give another option which is not possible. You can identify like that. So therefore, if they ask question on isomerism, there is only one possibility. You have to write all. There is no any shortcut. But remember these values. It is easy to identify the answer. That's okay. Because if they ask C9H20, so where is the time to write 35 isomers? And first of all, you will get confused there. And question can be asked. It is not mean that so how you remember and all, that is they don't bother. Okay. So question is previously asked actually. I think 7 or 8 they asked question. So it is about chain isomerism. Okay. Next, we will write what are the chain isomers of cyclohexane? What are the possible chain isomers of cyclohexane? Or question is, no, I am not asking a number. Right? Which are possible? Tell me. Very good. So therefore, it is cyclohexane, no, 6 carbon. You make it, 1 reduce. If it is 1 reduced, cyclopentane you will get. Then methyl. Next, cyclobutane, you will get ethyl. Cyclobutane, dimethyl. Cyclobutane, 1,3-dimethyl. Right? Next, cyclopropyl. Cyclobutyl 1,1. Okay. Cyclobutane 1,1 dimethyl. Next, cyclopropane. Cyclopropane, it is 1, 2, 3. Cyclopropane, again possibilities are no. Ethyl, methyl, dimethyl. Okay, and methyl positions like that. So in option they may expect which is not possible, which is possible. Which is possible, they may give any one of this option. Which is not possible, they make other options. So like these questions can be expected. Okay. So therefore, chain isomers differ in either parent chain or side chain. This is the parent chain. Now this is the side chain we have taken. Side chain 2 carbon, side chain 1 carbon. Right? So in this way you should identify which of the following are chain isomers. 1, 2 chain isomers. Which of the following are chain isomers? 1, 2, any 1, 2. All are example for chain isomers. So these kind of questions can be expected. Next is positional isomerism. Understand? Right. Positional isomerism. The organic compound which are having same molecular formula, but differ in the organic compound which are having same molecular formula but differ in either position of substituent over or multiple bonds or functional groups called positional isomers, and this phenomenon is called positional isomerism. Okay, tell me conditions. So what are the conditions for positional isomerism? 1, molecule must have same molecular formula. If molecule do not have same molecular formula, where is the question of isomerism? They are not at all isomers. Yaudu alla, ya isomer baralla. Okay, next, second condition. Second condition is, if there is a functional group, they must have same functional group. If, right, similarly, if they have like multiple bond, other molecule must have same multiple bond. If there is a substituent, other molecule must have same substituent. Right? Conditions. 1, they must have same molecular formula. They must have same molecular formula. 2, if functional group or substituent or multiple bond is present, if functional group or substituent or multiple bond is present, all the molecule must have same substituent, same functional group or same multiple bonds. For example, let us take CH3, CH2, CH2, Cl. It is a 1-chloropropane, right? Yes or no? What is the pi of this? It is a 2-chloropropane. 1-chloropropane, 2-chloropropane. Right. Then tell me, now 1-chloropropane, 2-chloropropane, whether they are Ci, chain isomers? Whether they are chain isomers? No. Chain is same. No. 1, 2, 3 carbon, 1, 2, 3 carbon. Chain is same. They are not chain isomers. They are pi, positional isomers. Similarly, if there is a functional group, for example, let us take alcohol group. Tell me, it is a propane 1-ol, propane 2-ol. So propane 1-ol, propane 2-ol, again they are example for positional but not chain, because chain is same. Okay, next. Okay, it is a but 1-in, but 2-in. So but 1-in, but 2-in, they differ in the position of multiple bond 1, 2. Right? Again, they are example for Ci, chain isomers. Sorry, positional isomers. Next, for example, 1, 2 dichlorohexane, 1, 3 dichlorohexane, 1, 6 dichlorohexane, 1, 4. 1, 2, 3, 4. Tell me. So what is the relation between these three? Their position, no. Chain is same. 6, 6, 6. Position of chlorine is different. Right? Next. Catechol, resorcinol, quinol. Example for what? Catechol. 2 OH groups are adjacent. Resorcinol. 2 OH groups are meta. Quinol. 2 OH groups are para. Their example for positional. Orthoxylene, metaxylene, paraxylene. Tell me, xylene. 2 methyl groups are adjacent. Orthoxylene. Metaxylene. 2 methyl groups are meta to each other. Paraxylene. orthoxylene, M-xylene, P-xylene. So, you can write many more examples. They are example for positional isomers. Okay, we shall continue next class. Today we have another class, right? Ilva? Physics, huh?